Good morning, everyone. My name is Lukas. I'm the sales manager here at Unisense Environment. Thank you for joining me today on this 30-minute presentation of the next generation nitrous oxide wastewater system. I hope you have your coffee on the go, and I'll take you through what's new here today. So if you're new to nitrous oxide measurement, this is for you. If you already run our earlier system, then this is also for you. We'll share how things have changed in practice. So the plan for today is to briefly go through what's new and why, the new system components, how the calibration works without a screen, and then a quick look at SCADA integration, and there'll be time for some questions at the end. All right, let's jump straight into it. Why was there a new generation in the first place? So we didn't just build this because the previous one needed updating, but we rebuilt it because operators told us what they really needed in their daily use, and we wanted to integrate these things. And here, 3 numbers really tell the story. With the new system, you can have 16 sensors per console. So one console can now effectively cover every relevant zone of a treatment plant, whether it's the aerobic, anoxic, side stream, reject water, all in one screen. Next, you need exactly 0 screens to calibrate these sensors. So the new sensor, in combination with the connector unit, walks you right through the 2-point calibration procedure with some LEDs. We have a video showing this in just a minute. And then we have the new digital sensor body, which logs all calibration data, lifetime tracking, and the sensor configuration, all live on the sensor itself rather than on the console as before. So the takeaway here is that it's the same proven measurement principle, the validated Clark type electrochemical sensor. What we've changed is how you work with it. So what's new specifically? We have the digital sensor, where everything about the sensor now lives on the sensor. You can move it to another tank. You can swap it between plants. You can replace the head. The history travels with the sensor body. Next, you can calibrate at the sensor. So you don't need to walk back to the console. There's an LED guidance on site, and it only takes a few minutes, which is a big time saver for the bigger plants. Next, we've integrated some smart sensor alerts. So the sensor, if you will, is self-aware, and it will tell you when it needs calibration or when the sensor head is nearing end of life before it affects the data quality. Next, we have direct nitrous oxide emissions results. So using some built-in dynamic emissions calculations, we can calculate using the live airflow input what the actual emissions are for a given tank. No need for external programming. And again, up to 16 sensors per console. We'll show you how that works in just a moment. So first, let's see what's in the box when you order a system from us. First, we have, there are 4 components now, as opposed to 3 before. The new member of the family here is the connector unit. We'll get to that just in a minute. First, we have the sensor head, the consumable item. Customers that have our previous gen system will be very familiar with this. It's a Clark type electrochemical sensor available in 3 ranges, so standard, medium, and high, and they need to be exchanged roughly every 6 months. Then we have the digital sensor body. This is where a big change sits. It houses the digital amplifier, temperature sensor, and the EEPROM that stores all the calibration history. Then we have the connector unit, which connects up to 2 sensors and mounts very close to the tank. And this is where the LED-based calibration procedure takes place. And then, of course, we have the operator console, the brain of the operation, which can take up to 16 sensors, 16 connector units, all in series, and will connect straight to your SCADA using Modbus TCP IP and other options as well, of course. A key point to highlight here is the modularity of the system. So you can really start small with 2 sensors, 1 connector unit, 1 console, and then scale up without needing to change the architecture and as needed on your site. So then we have the fully digital sensor. This is really the biggest architectural change compared to the previous generation. Previously, the calibration data lived in the controller. So when you moved a sensor to a different area, oftentimes you would have to recalibrate. Now the sensor is self-aware and remembers itself. So you can move it, replace it, you keep the history. You can swap the head, move the body to a new tank. You can even move it to a different plant, and the calibration data and the history all come with it. As before, it has a built-in temperature compensation for the, as seen previously, of course, the 3 ranges with standard, medium, and high. The difference here being that the system auto-detects which type of sensor you've installed and then adjusts accordingly in terms of calculating the values. As before, the sensor body is built out of robust anodized aluminum and is made to handle the rough environments that are activated sludge. Then we have the connector unit, the new member of the family that didn't exist before. This is a small IP67 box that you can mount close to the tank. This connects up to 2 sensors via their respective 7-meter cables. You can mount it on a railing or a pipe, and then you can daisy chain these or mount them in series up to 16 units in a row, giving a full 16 sensors per console. I just enable the laser. Here we have status LEDs at the unit. Green is for power, blinking blue is for normal operation, and a solid red if something is wrong and needs your attention. So you can read the sensor health directly where the sensor is mounted without needing to go to the console. Then we have screenless calibration. The full 2-point calibration can be done using just LEDs, and more details on the next couple slides in that regard. Here at the connector unit, we also have the 4 to 20 milliamp in and out, where you can supply the airflow data input, dissolved oxygen input, and then we have the analog outputs to your SCADA for each respective sensor. Additional Modbus RTU for dissolved sensors is also available. A key point here is that the connector unit pushes the interface to where the work happens, at the sensor, at the tank, and not at the console. Then we have the console, the part that you see day to day. The numbers are 16 sensors per console, 16 connector units. If you want to set it up that way, then we have 2 years of measurement data stored locally, 1 year of calibration logbook saved locally as well. It's a live touchscreen overview of every sensor, the respective concentrations, temperature, raw signals, all available at a glance. You have the per sensor menus. So for every sensor connected to a console, you can check the calibration, alarms, graphs, and the overall emissions overview. As before, we have multiple user levels, so you can lock down the system for plant staff versus service techs and kind of pick what they see and what they have access to. And then, of course, we have the full traceability where every calibration is logged. And it's important to mention here that the console runs whether or not it's connected to the SCADA. So your data is never lost. It's logged internally first and then pushed out to the SCADA. Next, we have a brief video about the screenless calibration that's now possible using the combo of the connector unit and the sensor. I'll just press play here and walk you through it. Yes, so first you hold the sensor vertically up, tip pointing up for 10 seconds. The LED on the connector unit will then go to a steady violet, meaning the calibration procedure has started. This is using a built-in accelerometer, no buttons included. Then you place the sensor in tap water, so no nitrous oxide. The LED will blink violet while measuring. Once it reaches a stable 0 point, the light will turn to a steady white, which means that the 0 point has been set. Then you place the sensor in your nitrous oxide calibration solution. I'll wait 1 second to catch up with Martin here. You add the nitrous oxide calibration solution. You stir this for 10 seconds. During this process, the LED will blink white. And then once we see a steady green light, it means the calibration is done. It is logged, and you're welcome to put the sensor back into the process water. There we go, calibration complete. Important to note here that at any point you feel unsure of the procedure, if you tilt the sensor back up for 10 seconds, it goes back to the measurement mode using the previous calibration. Then once you're in a bit of a routine, as you saw in the video, the calibration can be done in under 5 minutes once you're set up. Now, important to note here is that the console is, of course, able to drive the calibration as well if you prefer a screen, but this method here is a nice addition, and not a replacement of the screen, whichever you prefer. Then in terms of smart sensor alerts and diagnostics, as said before, the sensor is self-aware and monitors itself. So you no longer have to remember when to calibrate or when to change the head. There are 4 primary things that it keeps track of. So first, the time to calibrate. So it will automatically alert you every 2 months or earlier, depending on the process temperature drift, if that has moved more than 3 degrees from the calibration point. It will alert you when it's time to replace the sensor head. It tracks the remaining lifetime. As before, we have the guaranteed 4 months, but it typically lasts 6+ months. And it will flag you when there's a baseline drift or end-of-life signals before it affects your data. Then more broadly, the sensor will keep track of the sensor health, so raw signal, calibration status, warnings, errors, all exposed over Modbus, and you could pull this into your SCADA and trigger alerts there as well. Then in terms of sensor and calibration logbook, we have 1 year calibration history, 2 years of measurement data saved on the console, which is good for traceability and reporting. The key point here being that this system then turns your nitrous oxide monitoring from another thing to manage to a set and forget instrument that notifies you when it needs you. Another highlight of this new system is that it can actually calculate dynamic emissions for you. So while a concentration value is interesting, your sustainability team or regulators really want the number in terms of emissions in kilos per day. So this is what the system is able to calculate directly using 3 main points. First, the nitrous oxide concentration from the sensor, then the temperature also using a probe built into the sensor body housing, and the airflow data fed to the connector unit via 4 to 20 milliamps from your aeration system. So this built-in engine handles both aerated and non-aerated zones and is able to differentiate these in the resultant calculation. So in terms of outputs, we have grams nitrous oxide per cubic meter per day, which is more relevant for process control. And then we also have the kilos of nitrous oxide per day, which is more relevant for reporting and for regulatory submission. Plus, we have a whole suite of aeration metrics that we're rolling out soon that will be more relevant for operators trying to tune their aeration strategy. So the highlight here is that we have dynamic input parameters, or the possibility to integrate these, which means that the calculation follows the real process, not a fixed factor or a lookup table. And in this case, there are no external calculations or Python scripts needed unless that's the way you would prefer to do it. Then I won't get into this in too much detail, but this is built with integration into your SCADA system in mind. So we have all kinds of standard systems in place, whether you want 4 to 20 milliamps, Modbus, Profibus, these are all, or prefer to download the data via a USB stick straight from the console. We are able to plug into your system regardless of what you prefer. Then if we really look at the previous gen with the new generation side by side, previously for calibration, this was done only on the controller, and it could be that this would be up to 100 meters away from the actual sensor placement. So today, you're able to calibrate directly at the sensor without a screen. In terms of configuration, this was previously stored on the controller, meaning you had to calibrate when a sensor was moved, whereas now this is happening straight on the sensor itself. In terms of capacities, this is where we've seen a lot of growth. Now you can connect up to 16 sensors on one console as opposed to the 2 previously. In terms of emissions and emissions model calculations, previously this was based on static factors, whereas in the new generation, these are dynamic calculations using the plant's or that specific tank's live airflow data. In terms of diagnostics, previously it was a bit limited, and now with the new generation, we have the full health, lifetime, the raw signal, all exposed over the Modbus. So while the measurement principle is identical, and your data series stays comparable between the generations, we have just changed the workflow, and we're certain your operators will feel that from day one. So just to wrap it up, it's the same nitrous oxide with a new system. It's the same clock type electrochemical sensor with the same validated emissions calculations, but rebuilt around how you actually prefer to work with the data. So in the broad scheme, you will spend less time at the controller and more time at the plant. We have better diagnostics. The sensor will tell you when it needs you, and it scales with your plant, up to 16 sensors, 1 console, 1 data stream to your SCADA. So for existing customers, we welcome you to talk to us about an upgrade path for your current installation. And for new customers, we're happy to walk you through what a deployment at your plant would look like. So with that, I want to thank you for your attention, and I'm happy to take any questions.